In this video, we're going to learn how to interpret scatterplots. A scatterplot tells us about the relationship between two variables. This graph is a scatterplot showing the relationship between the mass and height of Star Wars characters. Each point on this graph represents a particular Star Wars character in the Star Wars dataset. Each of those characters has some value for the mass variable and some value for the height variable. That character is plotted where those two values intersect. Once we've created this kind of graph, how can we go about describing the patterns that we see in the graph? Well, one of the first things that we can say is whether the relationship is linear. Linearity basically means that you can draw a straight line through the data that represents the essence of the relationship. If you draw a line through the data and that line is straight, which means that it has a constant slope, then the relationship is linear like you see in the graph on the left. The alternative is that the data is nonlinear. This means that a line drawn through the data is curved like you see on the right. If we have a linear relationship, we should also say whether it is positive or negative. If the line moves upwards to the right, then we say the relationship is positive. If it goes down to the right, then the relationship is negative. A positive relationship really just means that as one variable goes up, so does the other, whereas a negative relationship means that as one variable goes up, the other decreases. What about if one variable is unaffected by a change in the other variable? In that case, you would see a graph like the one on the right here, in which a line through the data is horizontal. In this case, we would say that there is no relationship between the two variables. Another aspect of a scatterplot that we can describe is the degree of correlation. This just means how close to the line does the data lie. Both of these plots show a linear relationship, but the x and y variables are highly correlated on the left and poorly correlated on the right. The human eye is easily deceived by some patterns, and correlation can sometimes trick us into thinking that a linear relationship is nonlinear. This graph, for example, might look nonlinear, but a line through the data capturing the trend of the points is linear. What is actually changing is the degree of correlation. The correlation between x and y is very good in the left side of the graph, and quite poor on the right-hand side of the graph. Let's go back to our Star Wars graph from the first slide. How would you now describe this relationship? Pause the video for a moment and determine whether the data is linear or nonlinear, and whether the relationship is positive or negative, and whether those two variables are highly correlated or not. What did you think? It might not be easy to tell in this graph, because it illustrates an unfortunate truth that real data is never as nice as the contrived examples that your professors like to show you in lectures. In fact, this real data set has one point that lies miles away from the others, and makes the overall pattern hard to interpret. We call points like this outliers, and they are another thing that you can describe in scatterplots if you see them. In this case, we might decide to ignore the outlier, especially since the rest of the data does seem to show an interesting pattern. That pattern seems to indicate that there is a positive linear relationship between height and mass. And if you think about it, that's not too surprising. As you get taller, you generally get heavier, even if you live a long time ago in a galaxy far, far away. But this begs the question, who is the outlier? Perhaps you might have guessed, but if you were to examine the dataset, you would find that the outlier is none other than Jabba the Hutt.